Hello everybody, my name is Benji, and welcome back. It has been a minute since we had a recap episode, just because I have been absorbently busy getting a conference paper together. And so I didn't really have all that much time to actually do YouTube things or Satisfactory things. I've really only turned on my computer recently to play Satisfactory for stream, and that's about that's about it. Things have been busy, things have been crazy, things are going well. So the last time that I did a recap, I remember that we went through the entirety of this facility here, and it looks like I still need to go through and get rid of all of this cross marking. So we've got the copper in the top left, iron and steel in the top right, as well as SAM and fixite trigons. We've got all the caterium, quartz crystal, silica, copper powder, and then last but not least, the concrete overall. And we've got just an absorbent amount of resources coming into the train line, and all of the facility actually fit in the same blueprint size, or in the same footprint size as the trains. So in hindsight, I guess I could have had this on top of that, and that would have been pretty cool. But overall, I think that this is pretty cool in and of itself. So today, we're going to go through the new facility that I have started, which is the intermediate processing facility. So we've got the smelting facility, which is the first half of Thrust 4, and then we have the actual intermediate processing facility here, which is the rest of Thrust 4. And then we've got a couple of belts, as you'll notice over here, that will go off to another facility, which is going to be Thrust 5. That facility is going to go through all of the things that are space elevator parts. So it's going to go through smart plating using this alternate recipe. It's going to go through modular engines, thermal propulsion rockets, the ballistic warp drive, and all of the other things, magnetic field generators, AI expansion, versatile framework, all the different space elevator parts are going to be made over there. So every now and then you're just going to see some little parts branching off and going off to the Thrust 5 facility, which has not been started. That, first of all, just includes the steel beams. We're also going to split the plastic and run that here eventually. Reinforced iron plates, and a couple of other things. So let's go on ahead and start talking in the order that I built them, and just start talking about the facility that we've got here. So, first things first, we went through and did the steel parts. So we've got steel beams being made here with the molded steel beam recipe. That's what most of the concrete is used for, is steel products, which is kind of cool. And those steel beams are literally only used in one thing. Those are used in the versatile framework using this recipe, the flexible framework. So we're also going to need rubber going over there, just because it's a little bit more steel efficient for this. And by a little bit, I mean literally double the steel efficiency. Same modular frame efficiency, literally half the steel for the same amount of versatile framework, and just add a little bit of rubber, which is pretty much free. Just oil and water and call it a day. So that is why we only have 30 of these, because we really don't need all that much versatile framework in order to make this whole thing work. Steel pipes, on the other hand, are a bit of another story. Again, using the molded alternate recipe because it's more efficient for the steel pipes. We're making 800 steel pipes per minute, and these go to a whole lot of things. So if I look up steel pipe, and we take a look here, first of all, you can see this is a 3:2, this is a 1:1, so it's a lot more efficient that way. Didn't want to use this recipe even though iron is abundant, because there's already so many smelters going on, so steel is just easier. These are going to be used in stators, although not with this recipe. Steel rotors, which we'll get to soon. Steel frame, there's the quick-wire stator. Encased industrial pipe, and the heavy encased frame alternate recipe. So that is 1, 2, 3, 4, 5 recipes that this is going into, and that is a lot of things for steel pipes. So we're making 800 of those per minute, which is why it's on a Mark 6 belt. And that is quite a hefty use of our initial concrete supply here being used for all of that. And then we have all of our iron processing. So this is literally all of the iron ingots. It's also literally all of the steel ingots being used there, which is why the bus kind of shrinks and it ebbs and flows and grows and metastasizes like a cancer. It's great. We're having a great time. But we've got all of the steel being used. All of the iron goes over here and makes us our iron plates, which are used for reinforced iron plates and singularity cells, oddly enough. Singularity cells are the final use of concrete once concrete has been used for everything else. So iron plates and concrete, really weird items to see with something like nuclear poston and dark matter crystals also in the production chain. But that's okay, it's just singularity cells. So we've got a whopping 500 iron plates per minute, 400 of which go to the reinforced iron plates. And then, of course, reinforced iron plates are the only endgame item that ever requires screws. Because in the late game, you can have alternate recipes for everything that requires screws, except for the reinforced iron plate. I guess, I mean, there's the stitched iron plate recipe, but it's very iron inefficient, and the adhered iron plate, which is just a lot more rubber that I didn't want to deal with. So I guess I stand corrected. You could completely remove screws from your production chain. But I feel like it's easier to work with screws for the reinforced iron plates, just because it's a ratio that is very familiar. Rubber would just be too much of a hassle. Stitched iron plate is just a lot more copper. We already have, you see, 2 belts of copper over here. And that's just a lot. That's just a lot of copper. So we don't want to do that. But everything else that uses screws can be replaced with something that doesn't use screws. Like the heavy modular frame and modular frame line is something that doesn't use screws. But anyway, we're making 800 screws per minute, same amount as the pipes over there, the steel pipes. And then with those, we are making 66 2/3 per minute reinforced iron plates, some of which go off to the smart plating in the Thrust 5 facility, which hasn't been made yet, and the rest of which go into crystal oscillators and modular frames down the line. So these items get added onto our sub-bus, because we've got our main bus, which is all of our raw resources, which is shrinking. And then we have our sub-bus here off to the side, which takes all of our processed resources, and it's just growing the entire time. Then we moved over here and we started using all of our copper, and by all of, I mean quite a substantial amount of our copper. If I remember correctly, and by remember correctly, I mean I'm looking at all of my signs and everything else. We're using 480 copper off of this bottom line, which was 960, I think, on the bottom line. Where's my copper notes? Yeah, 960 and 720. So we've got a 960 belt and a 720 belt. Half of that 960 belt is going into copper sheets, and then the 720 line is going into the copper wire off to the side. And then some of that copper wire goes to the cable, the rest of the copper wire goes somewhere else. So we've got all of these making our copper sheets, and then we have all of these making our copper wire. And then that copper wire simply just comes all the way up the belt, and some of it goes off to the side, and the rest of it goes off to our wire. So I've got some really, really funky priority merger shenanigans going on here. I've got 2 inputs, the left and right, coming from the same input with high priority, and then this smart splitter actually, I'm not sure what's happening here now. I'm gonna have to double check my numbers and make sure that this isn't supposed to merge with everything, because it has to have a purpose, and I'm noticing that that's an error. So wire is used in cable, automated wiring, and rotors. Oh, I know what's going on here. Okay, so the right output goes to the automated wiring, because the automated wiring is a space elevator part. So that is going to end up going over to the Thrust 5 facility. I'm getting it now. I'm getting what Past Benji is putting down. So this overflow output needs to go to the other facility. Meanwhile, the rest of it, the priority here, goes into a very low priority merger. That way the copper cabling and then the rotors are prioritizing coming off of this. And then the rest comes from here in a really roundabout way. Very, very interesting logic there. And then, of course, we have all of our cable. The 240 cable per minute being made right here, which is very nice. That cable is used only in crystal oscillators, oddly enough. That's the only thing that this cable is used for. And then similarly with the copper sheets, the only thing that the copper sheets are used for is the circuits, which we'll get to here in a moment, because that's not the order that we built things. Then we went over and did all of our aluminum processing. So all of the aluminum ingots are being used here, so the bus gets to shrink a little bit, as well as some more of the copper, aka all of the rest of the copper gets used here. And that is making us our alclad aluminum sheets at a pretty decent rate, 90 per minute, it's not terrible. But then more so, all of this is actually used for the aluminum casings. 150 per minute, there's 4 machines here, that is 600 aluminum casings per minute. The alclad sheets are only used for the superposition oscillators, which is why there's not that many of them, but the alclad casings here, the aluminum casings, are used for heat sinks and fused modular frames, so we need quite a handful of those wonderful things. So you can see at this point the bus has shrunk quite a bit from its very tall stature over there. The silica is actually kind of up next here, which we'll get to in a moment, so that's going to be removed and it can go down another tier. And then the quartz crystals are used in a couple of different things. I think the quartz crystals are used in the superposition oscillators, the crystal oscillators, and the radio control units, which is why there's just so gosh darn many of the darn things. Plastic, you'll see, is gone, because plastic is used over here. We'll get there in a minute. And all of the rest of the caterium is used here. And then, of course, the fixite trigons and the copper powder are going to be somewhere else. Actually, I think the copper powder can probably just be taken off of this, because the copper powder is only made in nuclear pasta. Yeah, I'm not really counting nuclear pasta as a project part. Even though it is, I'm not really counting it as one, just for ease of building, I guess. So, okay, let's go on to the next thing that we built here. So you can see we're taking 2 of our sub-bus items. Now we're getting into the sub-bus items instead of the main bus items. Our copper wire and steel pipes, as well as some of our caterium. The caterium's making quick wire. The steel pipes and wire are making rotors, the steel rotors. And then the rest of the steel pipes and all of that 720 caterium wire per minute, or quick wire per minute, are making our stators. 96 stators per minute, 75 rotors per minute. It's great numbers. Then, of course, some of those rotors and some of those stators have to go over and make other processes in the Thrust 5 facility for the space elevator parts. But the rest of them come over here and make motors. 35 motors per minute is probably the most motors per minute I've ever made for a dedicated factory in and of itself, which is kind of interesting and going to be very exciting. The motors, what are the motors used for? The motors are actually used for a lot of things. The cooling system, the modular engine, which is why they're going off to the side for the modular engines, and then, of course, turbo motors, because who can forget that turbo motors exist? So these are going to get added into the sub-bus here as soon as I figure out what the heck the sub-bus is doing. But you also notice that the stators are coming right the way over here. So we can talk about that next, because this is the next thing that we did. We're using the last little bit of our caterium here, and then the rest of the last little bit of the caterium will go to the next product. We're making some quick wire, combining that with plastic to make our AI limiters, instead of using copper sheets, because it was easier and cheaper. And then with those AI limiters and our remaining stators, we're making electromagnetic control rods. And those electromagnetic control rods are only used in the magnetic field generator. So this is going to have to join up with the copper wire in order to go over to the Thrust 5 facility somehow. Probably just going to shoot it along this line here and get it over there and join it up. Then we've got our circuit boards. So we've got, oh gosh, how much? 115 per minute, I think is what this ends up being. And that is literally all of our plastic. All the copper sheets, all the plastic are used for circuits, other than the little bit of plastic that goes over to the Thrust 5 facility. I know it's getting quite complicated here, but the next thing up on the list is our high-speed connectors, because high-speed connectors are very, very, very important. And that is going to be the rest of our Caterium, making all of this 1620 quick wire per minute in 27 constructors, which is kind of crazy. We're going to use that blueprint again. 735 silica, that is literally all of the silica going into this. And then 54 of our 115 circuit boards are also going into this. The rest of the circuit boards go to computers and adaptive control units, which means the adaptive control unit part, they're going to have to go over to the Thrust 5 facility. And sometimes I wonder why the heck I am making a Thrust 5 facility when I could just make the space elevator parts locally. I'm committed at this point. It's going to look cool when we're done. I'm convinced. And that is going to be in a whopping 18 of these behemoth manufacturers. I don't even have a good blueprint for those yet, so that's kind of going to be the first thing next time, is making a good blueprint, because this, let's be honest, this is not a good blueprint. This is a very haphazard blueprint. This is not good. So we're going to make a better blueprint for the manufacturers in order to stamp down an absolute metric crap ton of these guys. Now, I could do, well, I don't know, I could do 8. That's 18 divided by 8, 2.25. I could do 8 at 225% clock speed, but these things are behemoths in terms of their power supply, 55 megawatts. And let's be honest here, we're already getting kind of close to what Red Heaven is producing. We're like 2/3 of the way there, give or take. Our actual active consumption is not that bad. However, it's gonna get worse. It's gonna get worse once all of these machines are constantly running. Right now, there's only a few machines that are still actively running, just building up a backlog of different things. I mean, like the copper sheets are kind of still producing a little bit of a backlog. Copper wire is still doing things because this is still doing things, and the stators are still doing things because the motors just finished backing up. Obviously, these are still backing up, so once all of this is like fully turned on and all of the buffers start to run dry and the ratios start to happen more perfectly, oh boy, it is gonna be a heck of a time. An absolute heck of a time. But that's kind of where we're going next. We're going to do the high-speed connectors in the manufacturers, and then we're going to go down the entire modular frame route. Why did I do that? There we go. We're going to go down the entire modular frame route, which is going to have all the steel pipes and the encased industrial beams and concrete and all kinds of other wacky, wonderful things that are going to end up happening. Not to mention, of course, as well, all of the more advanced things that are going to end up happening way down the line: the radio control units, cooling systems, heat sinks, supercomputers, crystal oscillators, computers, pressure conversion cubes, nuclear pasta, turbo motors, and a few other things, the neural quantum processors, and etc. So, in 2 streams, this is all we've done so far. There's a lot of math and buffering and estimating that goes into this project. And some of it I've been able to do behind the scenes, some of it I have not been able to do behind the scenes, so we end up doing it on stream, and that takes time. But that is a-okay, because I like kind of showing off the process a little bit, and making it known, like, just how much effort, just how much, you know, thought and workarounds goes into a build like this, where we're going to be making an immense amount of the final, most complicated parts in the entire game. Months of planning, lots of spreadsheets, lots of in-game hours are going into this project, and I'm happy to have you all with me for most of the steps of the way. But that is going to be all. I'm going to be in Boston this week, which is why you're getting this instead of a stream on this wonderful, fine Monday. And then I will see you all on, I'm trying to buffer to get the date, Monday the 18th of August. And then I will be back into streaming regularly, probably until my wedding. I don't think I'm going to stream on the Monday after I get married. So look forward to that little hiatus in September. But yeah, in that case, that's going to be it for now. So, thank you everybody so much for watching. I hope you've enjoyed. But without further ado, adios, sayonara, au revoir, hasta la vista, das vidania, auf Wiedersehen, ciao, and goodbye. Please have yourselves a fantastic rest of your day. Get some sleep if you need to. Don't forget to stay hydrated. This stream is in the bag. I'll see you all in the next one. Later, y'all.